Okay, so probably for some here and there, there'll be a question at the top of the note sheets where you will do that math question in the Google form, and then we'll talk about it together. It only counts for points that you have completed it. It doesn't count, for point, otherwise for correctness. We want you to do the best you can, but okay. So let's take a look. If we want to find -3 as an input to our function, the problem comes from the way that you write it, okay? Because the -3 squared means -3 times -3, which becomes a 9. That does not include the front, did I do somewhere? Oh, that's a 2. It does not include the front negative symbol. So it's the opposite of -3 squared. So it's the opposite of 9, which is -9. Okay, and then we have that multiplication of 2 and -3, which gives us -6, for a total of -15. So when you input that number, you get out an output, and that you're done. So they're just checking your order of operations here. So you should have answered F as your option. Okay, so hopefully you answered F as the option. We're going to go backwards a little bit. We are going to work on some of our algebra skills. I think it's better for us to kind of slow down a little bit, really focus on some of those algebra skills before we do anything too crazy. So today we're going to be talking about monomials and some of the rules about multiplying and dividing them. Okay. So if you want to open this up, remember you're going to make a file. Do not make a copy because you're going to need to write on it. So remember, you go File, Download, PDF, Open and Edit. File, Download, PDF, Open and Edit, so you can write on it, okay? Okay, so a monomial, what is it? Well, it is one term of a polynomial. The prefix poly means many. The prefix mono means one. So if that helps you to remember, it's a one-term polynomial. There'll be no plus or minuses of more than, multiple things. So you can think of it as a one-term polynomial. There are some rules we have to talk about. To multiply monomials, okay, the front values, the a and the b in this case, those you would multiply separately. So just do whatever those numbers are, a times b, follow the rules. The x's, the rule is if the bases are alike and you're multiplying, we're going to add those exponents. So that x, we have to add the n and the m as we go together. So the rules are, if the bases are alike and we're multiplying, we add the exponents. If it's a plain old number, we do the rules of plain old numbers. Two negatives multiplied together gives you a negative. I'm sorry, two negatives multiplied together gives you a positive. Only one negative will stay negative. So you got to remember those rules as well. So in our first example, you kind of want to separate the 2 and the -5, and you want to do that multiplication first. 2 times -5 is -10. So pull those numbers out first. And then if you take a look at the x's, think about what we've got. We have 2 of them and 4 of them. We have a total, because we're going to add those exponents, of 6 of those. And then our y, do the same thing. We have 3 of those and 2 of those. We have a total of 5 of those. Now, the reason that works is because multiplication is what's called commutative, meaning we can put it in the order that makes most sense for us And 2 times 3 is the same as 3 times 2. So x times 2 is the same as 2 times x. We can jumble up the order a little bit as long as we include everything in the process. So I've used the 2 and the -5. That's where the -10 came from. I have a total of 6 x's multiplied together. I have a total of 5 y's multiplied together. Now, division uses the opposite rule, okay? So we can divide those front numbers and just make them like a fraction. So a divided by b would be a over b. Now for the x's, we are going to subtract the exponents. So you're going to subtract your exponents. And it's always the first thing that's in front of the division symbol, that power n minus the one you're dividing by. So in example 2, when it says to simplify that, it's always, when it's written in fraction form, it's always the top power minus the bottom power. So x to the 7 over x to the 4th would become an x to the 3rd. Now, the way you can think about it is if you wrote what the top means, that's x written next to each other multiplied together 7 times. And then it's on the bottom, that'd be x multiplied together 4 times. If we crossed out 4 from the top and also from the bottom, we would have 3 left. So there's many ways to do these and still get the exact correct answer. Next, we're on to negative exponents. What a negative exponent refers to is it refers to division. It is another way to write division. Now think about the rule we did here. We were dividing by an x to the 4th, so we subtracted 4. That negative is important. It means that we are really dividing by an x to the n. Many times mathematically, we don't want to see a negative exponent, so we rewrite it as putting that x in a denominator. So I'm going to show you example 3 2 different ways, okay? If we just write it out, we've got 5 p's in the top, and 9 p's in the bottom. 5 of the p's divide from both pieces. P divided by p is 1. So it leaves 1 in the top and 4 extra p's in the bottom. And if you look over on the side, we've got 9 p's in the bottom. We have 4 extra p's when canceled out in the bottom. So that's one way to think about that problem, and it's perfectly correct. Now, what's another way to think about it? So let's do it one more time. Another way to think about it is if we use the subtraction rule we saw right here and here, okay? It means that we can take the top power minus the bottom power. So 5 minus 9, okay? Which gives us an answer of p to the -4, which when we combine with this one, negative exponents need to be flipped. And so we will get 1 over p to the 4. So either one should get us to a final answer of 1 over p to the 4th. I don't care how you think about it, but I want my final answer, please, to be a positive exponent. So if you get a negative exponent on top, flip it down to the bottom. If you get a negative exponent in the bottom, flip it up to the top. So that's just your rule, okay? Another rule about exponents that you want to remember, anything to the 0 power is also always equal to 1. So in example 4, we have this whole thing to the 0 power. So that whole thing becomes 1. Now, if we had just something on the outside and something on the inside to a 0 power, the inside thing becomes a 1, but the outside thing does not. So be careful that the parentheses includes everything, because only the things that are inside the parentheses on a 0 power become 1. So here, the 4 is included and becomes a 1. Here, the 4 is not included and does not. So just watch that difference, okay? Just watch that difference.
Not speaking. Hey. No, I forgot him. Okay. Thanks. Bye.
Okay, let's keep going. There's some more properties. So let's kind of summarize the properties we have so far. If the bases are like and you're multiplying, add the exponents. If you're dividing, subtract top power minus bottom power. Negative exponents should always be rewritten as a positive. Just flip whatever it's touching. 0 exponents become 1. Now, there's also a power to a power. A power to a power, this is when you actually multiply. So then a power to a power, if you have something to a power and it already has a power, you're going to multiply its power by the outside power. So m times n would be your new power. If you have more than one thing on the inside, each one of those things power originally gets multiplied by the outside power. So if they don't have anything, the reason they turn to m is because if you don't see a power, it's a 1. So 1 times m is m. Even if it's a fraction, that power on the outside affects both the top and also the bottom, okay? Negative exponent's job is to flip it. So if that m is negative, you want to flip it and then use the m. And I'll show you some examples like that momentarily. So those are some really important rules that we want to make sure we remember. So I have some different types of examples in example 5 that allow us to kind of deal with all of those properties all at once. So those product properties that we have there, or those power properties. So for A, you are just going to multiply. You keep the base, you multiply the exponents. Now the reason that is because technically that's an a to the 4 times an a to the 4 5 times. And if you use the adding property, if the bases are like and we're multiplying, we add the exponents. 4 plus 4 plus 4 plus 4 plus 4 is 20. So it's just a nice shortcut way to do that. Let's put, we don't have a power here, so let's make a power there, 2. Put a power of 2, please, on the outside. Now, that 2 on the outside affects all of the things on the inside. We're going to square a negative 5. We're going to square the p squared, which doubles its power. We're going to square the s to the 4th, which doubles its power. Now, you don't have to do it in 2 steps like I've done. I'm just kind of illustrating my point. Since the negative was inside of the parenthesis, the 2 is going to make the negative multiply by a negative and get you a positive 25. If the negative was on the outside of the parenthesis, it would not be included in the calculations. It would just come along for the ride. But since the negative's in the parenthesis, we're going to square the negative 5. So just be careful on that. If the parenthesis is there or not, it will make a difference. If you get an even power on a negative, you're going to get a positive answer. If you have an odd power on a negative, it's going to stay negative. Like 3 negative symbols stay negative, but 2 negative symbols become a positive when multiplied. So this 4th power, we're going to take negative 2 to the 4th, m to the 4th, and n to the 4th. Now, if you can do negative 2 to the 4th in your head, go for it. or you can use a calculator. -2 times -2 times -2 times -2. 4 negative symbols will multiply to give us a positive. 2 times 2 times 2 times 2 is 16. So the final answer I would want is 16 m to the fourth n to the fourth. And as long as you end with a positive power everywhere, then you're done. That's as far as you have to go. And then we have 2 more to go. Now, if you have a negative exponent on the outside, okay, if you have a negative exponent, what you want to do is you want to use the negative exponent as a flipper. That is the only job of a negative exponent, is to flip whatever it's on. So if it's on a fraction, it takes and makes it the reciprocal of that fraction. You might notice on the red calculators, there is an x to the -1 button. That is denoting a reciprocal. That's the reciprocal button. If you never knew what that button was, it is denoting a reciprocal because a -1 power is going to flip something. So what I do for one like D is I use the negative power, flip it upside down, then use the 2. So now it's going to become 3 squared over a squared. Now, a squared we can't do anything really about because we don't know what a is. But 3 squared finally give me a final value for that and make that a 9. Unless that power is like a power of 10, 3 to the 10th or something that's so huge. If it's up to almost like a 5th power, do it. If it's anything more than that, feel free to just leave it. Okay. And then our last example here is E. We've got a cube on the outside. Now, here's my take on one like this. If you can simplify the fraction first, if there's anything that can be simplified, I would do that first. Okay, so does anybody notice what variable is on top that's also on the bottom? What variable on top and on bottom is an x? So where do we have an extra x? Do we have one extra on the top or one extra on the bottom? We have one extra on the bottom. So let's just simplify that fraction first. You know, think about order of operations. They say to do inside a parenthesis first. So if that fraction can reduce, do it. It's going to make your life easier later on, okay? Now we're going to cube everything. Now we have to cube every single piece of that fraction. To cube the top, it's just -4 to the 3rd power. Now, -4 times -4 times -4 will be a negative. 4 times 4 times 4 is 64. Okay. To cube the bottom, each original power gets multiplied by 3. If you don't see the original power, feel free if you want to put a 1 there. That's what it's implying, that you have 1x if you don't see a power. 1 times 3 is 3. 2 times 3 is 6. So it would be a final answer of -64 x cubed z to the 6th. So lots of rules of powers. You may have forgotten some of those. So I think this is a good place to kind of review some of those rules. So, and if you look, your homework is on the next page. You're only doing odds, except for these little ones here. You have the remainder of today's class. You have all tomorrow's class, or in the next time I see you, to work on this. So there you go.